In this previous neural networks tutorial, I was using AND as training data, so 0 and 0 and 0 and 1 and 1 and 0 will give us 0 and 1 and 1 will give us 1, and the 1 here is bias. So if I change this to an XOR training data, so now 0 and 0 will give us 0, and 1 and 1 will give us 0, and 0 and 1 or 1 and 0 will give us 1. And if I try to run it, it will go forever. So to explain what happened here, let me change this back and try to run it again. So for XOR we would have a 1 here and a 1 here and a 0 here, so 0 here and 0 here. So it would not be possible to have one line that separates the zeros and the ones. This is a pre-built version of the application. So if I go ahead and run it, we have three options, either to train or to run or to exit. So let's start by running it, and we have a big difference between the target result and the actual result. So let's try to train it. And now run it again. So here we go. The target result is the same as the actual result. So we have used a neural network with 5 neurons. 2 of those neurons are in the input layer, and 2 are in the hidden layer, and 1 is in the output layer. And each neuron has 2 inputs and a threshold. So the I here indicates input layer, and the H indicates hidden layer, and the O indicates output layer. And for this neuron, those are the 2 weights, and this is threshold. And here we have the adjusted error is bigger than the current error. So we stay. We don't climb the performance hill. And we have the same here and here until iteration number 5. So here we have the adjusted error is smaller than the current error. So we climb the performance hill, and we end up with the neural network with those weights and thresholds. And we keep doing this until here we stay for 200 iterations, and this is considered a potential maxima. So we ended up with those 5 neurons having those weights and thresholds. I will start by creating a new Java project. And here I will create a neural network class, that will be in this package. And a neural network will have neurons that are in one of three layers, either in the input layer, or in a hidden layer, or in the output layer. And I will have a neuron class that will have two weights and a threshold and an output, and it will belong to one of the three layers, either the input layer or the hidden layer or the output layer. And we will have get and set methods for the weight, the threshold, and the output, and a get method for the layer type. And we will have a hill climbing class where the hill climbing algorithm logic will be, and a class that will drive the application, and will have a main method. And I will be using XOR as the training data, and going to the neuron class, we will use the log sigmoid transfer function, and this class will have two constructors, one that takes in a layer type, and another one that takes in a threshold and an array of weights and a layer type. And we will have this adjust method that will return a new neuron having the same layer type as this neuron, and the adjusted weights and thresholds of this neuron. Now this should do it for this class. Next I will go to the neural network that will have two neurons in the input layer, and two in the hidden layer, and one in the output layer. So the total number of neurons will be 5. And this class will have an array of neurons that contain all those neurons, and a get and set methods. And we will have two constructors, one that will take an array of neurons, and based on that array it will populate the array of neurons for this neural network. And the other constructor will instantiate the two neurons that are in the input layer, and populate them with random weights and a random threshold. And the two neurons that are in the hidden layer and same thing, populate them with random weights and a random threshold. And the neuron that is in the output layer also will be populated with random threshold and random weights. And what we still need is two methods. A run method that takes in the inputs, in this case both inputs for the XOR training data, and a calculate root mean square error that will calculate and return that error. And this is the logic for this method. So the actual result will be what's returned from this run method. And this will be the target result, and we obtain it this way. And we square it, so we square the target result minus the result, and we add them all up, and we divide by the length of the training data, and we do the square root of the local errors over what we divided by. Now in the run method, we want to go through all the neurons and calculate the weighted sum and the activation, apply the activation function for the neurons that are in the hidden and the output layers. So we do a switch statement to check what layer a specific neuron belongs to, and if it is the input layer, then we set the output of that neuron to be what's coming in here as input. And let me define this index, and if this neuron belongs to the hidden layer, then in order to calculate the weighted sum, we start by adding the threshold to that sum, and then we want to go through all the neurons and picking up the ones that are input neurons, and pick up the output of those neurons and multiply it by the weight of this neuron that is in the hidden layer. So we end up with a weighted sum that we pass it to the activation function, and finally if this neuron is the output neuron, we do the same as we did here, except instead of checking going through all the neurons and checking which ones are input neurons, we go through all the neurons and check which ones are neurons that are in the hidden layer, and we pick up the output of those neurons and multiply it by the weight of the neuron that is in the output layer, and then we end up with a weighted sum, and we pass it to the apply activation function. And finally, we return the output coming out from the output neuron, so number of neurons -1. And this should do it for this class. Now going to the hill climbing class, we define this number of iterations before maxima, and for the purpose of this tutorial I'll have it be 200, and I will have two printing methods, one for printing the heading and another for printing the rows beneath that heading. And we will have two methods, one for climbing the performance hill that takes in a neural network instance, and another for adjusting the neurons in the passed-in neural network and return it for convenience. And this will be the code for adjusting the neurons. So I will have a new array of neurons, and then I will go through all the neurons that are in the passed-in neural network and call adjust on them, and then put them in this array of neurons, and set the neurons for this neural network. Now here we will start by calling the print heading method, and we will have this index and a while loop while this index is smaller or equal to the number of iterations before maxima. And here we need to pick up the current error by calling the calculate RMS error on this neural network instance. And we also need to pick up the adjusted error by calling the adjust neurons method, this method, which will return a neural network, and then we call calculate RMS error on that neural network instance. And now we have two cases. If the adjusted error is smaller than the current error, so we will be climbing the performance hill. And let's define this string buffer instance containing the current error and the adjusted error. And if the adjusted error is bigger or equal to the current error, then we have two cases possible. Either we have reached a potential maxima if the iteration to maximum counter is equal to the number of iterations before maxima. Otherwise, we hold on climbing the performance hill. And beneath the current error here, I need to pick up the neurons from the passed-in network, and I need to keep track of the current network. And in the case where we are climbing the performance hill, the current error becomes the adjusted error, and the neurons become the network.get neuron, and we go back to 1 for this index, and here we set the neurons and we increase the index. And let me do a print row here. Now going to the driver class, I need a method that will print the result of running the neural network. And this will be the logic in main. So I will be picking up what the user enters in the command line, and I will have an always true while loop. The only way to exit that loop is if the user enters exit. So we go here and we do system.exit. So I'm reading what the user enters here and prompting him here. We can enter either train, run, or exit. And if he enters train, then I'll instantiate a new hill climbing instance and call climb performance hill on it, passing it the neural network that I instantiated here. Otherwise, if the user enters run, I will call neural network.run on each one of these inputs. And populate this array of doubles with result and pass it to the print result method. Finally, let me go ahead and test run the application. So let's try running first and then do some training and running again. And here we go. They are the same. So we reached a potential maxima after 200 iterations.